test, test. Test 1, 2, 3.
Good morning, everyone. Good morning.
السلام عليكم.
مش موجود يا دكتور.
لينك بتاع اللايف عشان اللايف بس.
طب هقول لك على البحثين خد الفلاش. كله تمام.
Dr. Muhammad Khamis, can you hear me?
Yes, I can hear you.
Could you please share your paper and start presenting it?
Okay. Okay, can you see my slides? Is
Okay,
it
go on.
obvious? Can you see?
Yes, we can see your presentation and we can hear you very well.
Okay. I can start, right?
Just before you start, for each paper, we have about 20 minutes time limit.
Okay.
So we'll have about 15 minutes for presentation and 5 minutes for taking questions. So please
Okay.
stick to the time limit. Thank you very much.
Okay, you're welcome. Bismillah, salatu wassalam, Rasulillah. My name is Muhammad Khamis, and this is my paper presentation on the Hausa handwritten character recognition using CNN and Taser Act. Hausa language is among the widely spoken languages in West Africa. It has a population of 64 million plus people speaking Hausa language. But the challenges that Hausa language is facing in the recent technologies is that it is underrepresented in the recent technologies due to some factors. One of the factors is limited data set. So we try to bridge that gap by developing a data set and also developing a custom CNN model to test our data set and to compare with state of art. So our model performed 96% on our data set, and we also customized Tesseract, where we compare also the performance of Tesseract. And then contribution lies in the process of developing data set and also enhancing.
You have any problems in the communication?
No, I had like someone is talking, that's why. Okay. Our contribution lies in the developing of dataset and also the custom CNN model that we developed, which enhance Hausa recognition, which can also help in digitization, and also natural language applications. Introduction, we can see that Hausa language is one of the mostly widely spoken languages in West Africa, as we said. It plays a critical role in cultural and economical socio-dynamic of West African countries. But the digital processing of Hausa languages is particularly handwritten format remain less explored in research areas. Due to the lack of sufficient resources, data sets, and other factors. So if we work on this area or in this area, we can visually or potentially influence the socio-economical and educational domains in West Africa and the world at large. Therefore, we start with literature review. Our literature review start with Hawking, which emphasize on adopting OCR technologies to accommodate unique phonics and orthographic features of African languages. They also highlight the need to tailor OCR algorithms specifically for these languages, for the African languages. We also have DOSU, which advocates for specialized end-to-end system for low resources languages like Fon and Igbo. Also, Igbo is another language in Nigeria. They emphasize the need for counting for the unique linguistic characteristics and accent and tonal variation to ensure accurate language technology.
Dr. Khamis, sorry for the interruption. Could you please
Okay.
maximize PowerPoint presentation?
Okay.
Because the text is a little bit small.
Clear now? Is it clear?
Yes, it's clear now. Continue, please.
Okay. Also, the next literature is Abdullahi and Abdulmumin, which discuss the lack of resources and dataset for text processing in Hausa, especially handwritten formats. They emphasize that the importance of enhancing dataset for advanced technologies benefits social, economical, and political system and educational domains in West Africa. Also, Mukhtar indicates that most studies on Hausa focuses on higher level of AI application, like natural languages natural languages processing and speech recognition. They highlight that the gap in foundational research on character level is needed. Also, Ibrahim referred to the focus on content classification for Hausa, but indicates negligence in foundational aspect of language research. We also have Adams, and Muhammad, which also notes that studies on sentimental analysis for Hausa and mention that the need for focusing on core linguistic component is neglected. Therefore, it is needed to be enhanced. So after the literature review, we have summarized what we have intuitively acquired in the literature review, which is there's need for language-specific OCR, specifically for African languages. Also, there's a challenges in low resources languages like Hausa. And there is the importance of dataset for linguistic diversity and enhance the accuracy of models. Therefore, we developed our objectives in this research, whereby we try to build a dataset, handwritten character dataset, and develop a CNN algorithm to train it to recognize those Hausa characters. And we also adapt Tesseract OCR for to compare the performance of our developed model with the current state of art. Also, we compare the performance of those models, the accuracy and precision with the recall. So our methodology lies as seen here. We first of all collect a data set from 30 diverse volunteers. We have volunteers which are students from elementary school 4 to postgraduate students. And also after we collect this data, these diverse handwritten characters, we pre-process it. We employ different pre-processing techniques in that. We also have, we train the model. We train our CNN model, and then we fine-tune the OCR. We fine-tune the Tesseract OCR, therefore, so that it can only use Hausa, because the Tesseract is a very large model that comprises a lot of languages. But then we fine-tune it to use only Hausa language, and then we evaluate. We see which one we evaluate the model between the CNN and the Tesseract. So as we said, the data collection starts by ranges of level of education. We have, this is how we collect our data set from elementary school 4 to postgraduate students, which we have different number of volunteers. The participant, what we are going to observe here is that the participant educational level ranges from level of education, so that we can have different variation of handwritten characters, and so that our model, we can tune our model to accurately try to understand those handwritten characters. And we collect, that make us to collect around 884 total of handwritten characters. from those participants or volunteers. Okay, this is a sample of the handwritten character that we collected. We have 31 characters in Hausa, which comprises of single character, and there are some characters that they are combined, 2 characters at once, but they are pronounced as a character. So this is a total of Hausa handwritten characters with the different variation and tonal voice. So
Could you
during the
please
data
speed up a little bit because you have 5
time,
more
right?
minutes presentation.
Okay, data pre-processing. We pre-process our data by employing different types of pre-processing, grayscale conversion, and then we remove the background removal, and then enhancing the font or enhancing the stroke, then applying histogram, different type of pre-processing. I will also apply augmentation so that to enhance or to duplicate the number of data sets. So this is a sample of data set before pre-processing, and this is how the sample becomes after the pre-processing. And you can see how it is how the model try to understand which one is B, which one is O, which one is C, which one is H, address. Then the CNN model architecture. This is our CNN model architecture. We have 3 convolutional layers with ReLU activation. We have maximum pooling, max pooling, and dense layer for future extraction, and we have softmax for activation layers for the classification. This is the in diagram. This is how our model is developed. And the Tesseract, we adopt the Tesseract we fine tune it for Hausa specific characters. And we found out that there is some challenges because fine tuning the Tesseract specifically for a single language will have some challenges, which we discuss in the next section. This is our model training. We have, sorry, let me rise this up. Yeah. We have 20 epoch, learning rate 0.01, optimization, Adams, loss function. We use categorical cross entropy. Batch size, we use 32-bit, 32 regularization. We did not employ regularization, and we split the dataset into 80-20, 80 for training and 20 for testing. And this is the curve for the performance of our model. The model result. Therefore, the CNN that we developed has achieved 96% accuracy, whereas the Tesseract achieved 5% accuracy, which has some limitation that we are going to discuss in the end of this slide. Therefore, this is the confusion matrix of our models. You can see why it is 96, because there are some missing also classification based on our model. It misses like E with K, and also K with special stroke also is not recognized, which is toward the end of by the left side toward the end. We can see it is not recognized. So this is the confusion matrix of our model. And with the Tesseract, which shows that our model has reasonably performed great in recognizing the data set that we have. In conclusion, a limitation, the custom data set we developed, we designed, we have effectively handled some distinct characteristics of Hausa languages, which we have seen in the confusion matrix. The experimental results shows that the CNN outperformed Tesseract. The CNN achieved overall accuracy of 96%. The limitation of Tesseract, consider that Tesseract employs some punctuation marks like comma, semicolon, question mark, exclamation marks, whereas our own dataset does not contain that. Maybe one of the limitation of where the huge variation is, there is huge variation in the performance. Therefore, we in the future research we will try to implement some punctuation marks and some quotation marks so that we can also see the performance of Tesseract and CNN. This is the end of the presentation, and thank you.
Thank you very much, Dr. Muhammad, for the comprehensive presentation. Now, if anyone would like to ask any questions related to the work, we have any questions from the attendants or the online colleagues? Okay, I do have some questions for you, Dr. Muhammad, if you'd allow me.
Okay.
First of all, I have noticed in the slide that you have just presented, the confusion matrix, not all the alphabets are included there, because I have noticed that some of the alphabets contain 2 letters previously.
Yes.
So
Yes.
you didn't use the entire data set in your work, correct?
Yeah, exactly. We during the pre-processing, since our best aim is to identify each character. So those characters that they have 2 letters, we eliminate them during the pre-processing so that if we recognize one character, automatically we recognize the other character. That's why we just concentrate in one character. It's not that we have not used all the data set, just one that has 2 characters, we eliminate one character, because if we recognize one, it means we recognize the other one. So we did not employ the 2 character letters. We just use single characters.
Also, in the same slide, you have stated that the CNN had achieved an accuracy of 96% and Tesseract 5%.
Yes.
What makes that huge difference? You didn't mention the model that Tesseract used. I think Tesseract is from Google, correct?
Yeah. Yes. Tesseract from Google.
What is the
what make
learning model they use there?
what we are anticipating, the main reason is that I have mentioned it is like in Tesseract they use some quotation marks, exclamation marks, some punctuation marks, whereas in our data set we have not used that quotation marks, exclamation marks. This will bring a huge difference in performance also. And another thing is in Tesseract we have seen that it is not recognizing, it does not recognize the K in Hausa with like the quotation on it, the K in Hausa with the quotation on it, and the Y. There are 3 characters that they have not, that Tesseract did not recognize, giving it accuracy of 0, which is also will have impact on the performance in the general performance of the Tesseract. There are 3 characters that. Yeah.
I'm sorry, but yes, thank you for your answer. I have one more question about the accuracy itself, 96% for the convolutional neural network.
Yeah.
How did you make sure that this result is not from overfitting, and this is an actual
Yes.
result?
Yes, because we have because have to train and retrain and retrain to confirm your accuracy. So we have employed, since to prevent overfitting, first of all, we have employed the regularization. So the regularization does not perform any performance, does not affect any of the performance. And we remove the regularization like trials and error, remove and add. We have seen that the regularization is not adding or removing or affecting any performance of the model.
Convolutional neural network, the main concern for overfitting is not having enough data set. According to your presentation, you have 31 letters. I think you have excluded some of them, and you have an overall of 884 data set. Correct?
Yeah.
This is for all classes, for all letters.
Yeah.
Do you think that this is enough? And do you think that this
size
of data set may be the cause of the difference between the accuracy of the convolutional neural network and Tesseract?
It could be, but we have employed the use of what is it in the pre-processing. We have duplicated the data set so that to enhance the performance, to see that the performance, the number of data set is large. We also, because we have already used the same the same dataset we use in CNN is the same dataset, number of dataset we use in CNN, the same number of dataset we use in the Tesseract. Therefore, it should, since the Tesseract already trained on a large dataset, it should use its knowledge of transfer learning to adapt to this dataset actually, if that is the case. But it fails to do that. That means that our own dataset also, our own performance, CNN performance is can be accurately compared with the Tesseract also.
Thank you, Dr. Muhammad, for your comprehensive answer. We have any more questions from anyone? Thank you very much.
Khamis, you publish your data or not yet?
No, not yet.
Try
After
to
the
publish it,
presentation.
please.
Okay.
Try to publish it via maybe Kaggle or something like
Yeah.
that.
Okay.
Great work, inshallah. Thank you.
Thank you.
We're going to move to paper ID 71 with the title, A Hybrid Ensemble Deep Learning Approach for Detecting Polymorphic Malware. Dr. Nasser Al-Sharif will be presenting this paper. So please, Dr. Nasser, share your screen and start presenting your work. Please stick to the time limit of 15 minutes of presentation, and we will have 5 minutes for questions.
السلام عليكم.
وعليكم السلام ورحمة الله وبركاته. اتفضل.
الصوت واضح؟
أيوة.
بسم الله والصلاة والسلام على رسول الله. Hello, good morning everyone. My name is Nasser Al-Sharif. I would like to thank you all for your time. As you may know, I'm going to present my paper with the title, I have been Ensembling Deep Learning Approach for Detecting Polymorphic Malware. You know, as you know, cyber threats are growing with expansion of cloud computer and digital ecosystems. Malware is becoming more sophisticated, posing challenge to traditional detecting method. Polymorphic malware can dynamically change its structure and behavior, evading confidential security measure. Polymorphic malware have the ability to change its code structure while retaining malicious functionality, making it so hard to detect due to the sophistication of evolving cyber threats. Traditional signature-based and heuristic techniques have fallen flat, again, such as evolving threats. For more advanced strategies are required for detection. In this study, inshallah, we propose a hybrid ensembling deep learning approach to detect polymorphic malware by combining the strengths of deep learning model such as autoencoder, LSTM networks, and gradient boosting. Malware that alters its code structure while retaining functionality challenges traditional signature-based detection fails to recognize altered versions. The impact undermines cybersecurity defense and increased risks sensitive systems. Limitations of traditional and visual AI model in handling polymorphic malware, need of robust and adaptive and scalable detection method, objective, develop a hybrid model combining diverse strengths to improve detection accuracy. Traditional method, as we said, signature-based detection and heuristic analysis, machine learning and deep learning introduce improved capabilities. Recent advancement, feature engineering and ensemble method have shown promise. advancement in AI for cybersecurity, deep learning models, autoencoder, LSTM network, and gradient boosting strength handle complex pattern, adapt to evolving threats, and reduce false alarms. Hybrid approach combine multiple model for super performance. Components. Autoencoder, LSTM networks, gradient boosting. Hybrid ensemble uses weighted voting mechanism for final prediction. Strengths capture both static and dynamic feature of polymorphic malware. Dataset. Ember dataset contains 1 million samples, including 600,000 malicious and 400,000 Binion files getting from GitHub, downloaded from GitHub. Feature by its entropy, section size, onboard, and the purpose provides comprehensive dataset for evaluating malware detection. Feature selection. Recursive feature elimination identifies the most relevant features. Iterative process remove less important features to optimize model performance. Outcome reduce feature from 2,381 to 200, enhancing efficiency and accuracy. Autoencoder propose detect malicious by reconstructing data and analyzing reconstruction errors. Mechanism compress input into a lower dimensional representation and reconstruct it. Application high reconstruction errors indicate potential malware. LSTM network purpose capture sequential dependency and malware behavior. Structure uses gates, input, forget, output to manage information flow. Strengths detects staged or time-dependent malware actions. Gradient boosting mechanism builds strong classifiers by combining weak learners iteratively. Focus correct errors from previous model, enhancing detection accuracy. Outcome handle complex data pattern effectively. Weighted for voting mechanism process combines prediction from AE, LSTM, and gradient boosting based on weighted importance. Weights assigned based on each model's performance result improve accuracy and reduce false positive and negative. Our experimental setup, hardware and software MATLAB data set split 80-20, 80% for training and 20% for testing to evaluate model performance. Performance metrics. Accuracy measure overall the correctness of the model. Precision's proportion of correctly identified malware among all flagged sample. Recall proportion for actual malware correctly identified. F1 score balances precisions and recall. AUC evaluates the model's ability to distinguish between classes. Here the results without features selection and the result with feature selection. As we see here, the results without feature selections, encoder autoencoder accuracy here 95.67, and the F score is 0.95, and here as we see 97.12 and the F-score 1 0.95. Here without without LSTM accuracy 90%, 96.23, F-score 1 0.96. Gradient boosting accuracy was 97.02%. F1 score 0.97, and simple accuracy is 97.89%. If one scored is 0.98. Here, the auto, as we said, the auto encoder accuracy here is 97.12%. If score 1 is 0.97, LSTM accuracy 97.94%. If score is 0.98, gradient boosting accuracy 98.84. If score 1 0.98, and simple accuracy is 99.21. If 1 score 0.99. Conversion and analysis, feature selection, enhance accuracy and efficiency, as we see here with the result with the feature selection, and in simple model performs individual model a significant improvement observed in all metrics, making it practical for real world application. The conclusion. The proposed hybrid and simple model combines the strengths of AE, LSTM, and GB, achieves 99.21% accuracy and 0.99 if score 1 is detecting polymorphic malware, robust and scalable for practical cybersecurity application. Our future direction: explore real-time implementation, evolving malware, the threats, enhancing scalability and adaptability for the larger dataset, investigate applicability to other types of malware and cybersecurity challenges. This is our presentation. Thank you, sir.
Very much, Dr. Nasser, for your presentation. If any one of the attendants would like to ask any questions, go ahead, please.
Hello, is it working? Thank you for sharing your work with us. Sorry if I'm not paying enough attention to what you said, but you mentioned something about reducing the dimension of the data. Could you please explain it a little bit for us?
Dr. Nasser, did you hear the question?
No, sorry.
Thank you for sharing your work with us. And I'm sorry if I'm not paying enough attention to what you said. You mentioned something about reducing the dimension of the data. Could you please explain it a little bit for us?
Dr. Nasser, did you get the question? Dr. Nasser?
So I have something here.
Have you heard the question?
No.
Okay, I'm going to repeat the question for you. Our colleagues were inquiring about the number of features, the dimension of the data, and I have a question also on the number of features that you have reduced. So if you have anything to elaborate on that. I think we're having some issues in the communication. Do we have any other questions?
Nasser, you hear me? Salam alaikum. Nasser, you hear me? السلام عليكم.
Thank you, Dr. Nasser, for your contribution. Due to time limits, so we're going to move to the next presentation and time slot. Paper 97, S-shaped and V-shaped transfer function for SALP swarm algorithm in sentiment analysis feature selection problem. You're going to present this paper? Okay. No, just. Keep in mind. Okay.
Can I
So
test?
by the
Not function.
devices. I think it's okay, no problem. I need you to use the mic for your online colleagues to hear you. Any of the colleagues online, can you hear me? Hello? Hello, any online? المايك شغال تمام يا دكتور. Please use this one. They will hear you. Mic is working.
Okay, thank you so much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. So glad to see you all physically and virtually. My name is Dinar Ajeng Kristianti. I am a lecturer from Information System Study Program, Universitas Multimedia Nusantara Indonesia. I'm representative with the author, with Dr. Lee Ahmad Hairul Umam from Communication Science Study Program, Tanri Abeng University, Indonesia, to present our research paper. The title of this research is S-shape versus V-shape transfer function for subswarm algorithm in sentiment analysis feature selection problem. Please, next, sir. Well, it is the outline of our research, starting from introduction, research contribution, research methodology, result and discussion, conclusion and suggestion, and the last and presentation. Okay. Yes.
بدأت حاجة يا جماعة كان شغال دلوقتي.
Okay. Okay. Yeah. Oh. Okay. Okay. And the last is end presentation. Next. Okay. This introduction. If you look at this image or picture in this slide, how the forest and land fire that happened in Indonesia for the last a few years back, the extent of forest and land fire in Sumatra, Indonesia, in 2019 until 2023, for the last a few years back, is from this data we can see clearly the worst of land fire happened in 2019. It is in line with the public opinion on Twitter. There were 16,782 tweets. According to Hasbi et al. 2021, forest and land fire in Indonesia became a trending topic on Twitter in 2019. Okay, next slide, sir. There is a technique of automatization which is known as sentiment analysis to classifying public opinion like tweet from Twitter into three polarity, positive, negative, and neutral. But however, the sentiment analysis have challenges. The challenges of sentiment analysis less accurate and long process when faced with high dimensional data. And then, so there another technique, namely feature selection technique. Feature selection technique useful for improving sentiment analysis performance. The approach for the sentiment analysis using feature selection approach is NLP. The first NLP, the example is post, part of speech tagging, and non-NLP, filter, wrapper, and hybrid. For hybrid use meta-heuristic algorithm, and according to Agrawal et al. 2021, meta-heuristic algorithm successfully solve various optimization problems. The first meta-heuristic algorithm is PSO. PSO, particle swarm optimization. PSO was motivated by the corporative behavior of fish or birds that travel in group. In the context of feature selection, each particle in the swarm represents a set of features and advance in the search space to find the best combination of features that can maximize model performance. PSO have been widely used for feature selection technique in sentiment analysis for several years, such as sentiment analysis for product review on Amazon. PSO can produce accuracy of 90%. However, PSO have limitation. The limitation of PSO has limited memory. It is also limited in diversity, and its effect result in feature reduction that is sometimes less than optimal. And the second of meta-heuristic algorithm is Unlion optimization, ELO. ELO is an optimization algorithm that has also been widely applied as feature selection technique in sentiment analysis. With a 90% accuracy rate, ELO is used in sentiment analysis to identify the ideal hyperparameter value for the support vector machine algorithm. ELO obtained an accuracy of 96.30%. But same with PSO, ELO have also limitation. ELO also has problem with local optima and feature convergency. And the last of meta-heuristic algorithm, SSA. SSA is a bio-inspired meta-heuristic optimization algorithm based on swarm intelligence that can be used as a feature selection technique. As feature selection technique in further sentiment analysis, SSA is limited to Arabic dataset, which can increase accuracy by 80.80% according Al-Zakebah et al. 2020. However, the processing time is still superior to the particle swarm optimization PSO algorithm. SSA as feature selection technique for English dataset also increase accuracy. Although not much, only 1%, but the processing time was still too long, namely 545.5 until 600.67 seconds. According Kristianti, my last paper, 2023. Same with PSO and ELO, SSA have also limitation, only limited to use as feature selection technique in sentiment analysis for Arabic, Al-Zakebah et al. 2020, and in English, Kristianti et al. 2023 with long processing time. SSA typically converges slowly, especially in binary problem and large data. Okay, the transfer function is one technique to improve the some limitation optimization algorithm. Transfer functions are crucial for enhancing the binarization process, convergence speed, and accuracy in optimization tasks. SSA that has been improved using VTF has also been successful in English language sentiment analysis with an accuracy of 80.95%, and STF also been successful in English language sentiment analysis with an accuracy of 80.80%, according Al-Zakeba et al. 2020. Among the 21 transfer function types studied for converting continuous SSA to binary space are STF, VTF, XTF, UTF, and ZTF. And then this study focusing only 2 type transfer function, just only STF and VTF variant we choose the STF and VTF assume to simplify mathematical formulation and improve binary search, space navigation, crucial for feature subset update. And then this is research contribution. The first is present an enhanced version of the SSA for feature selection by integrating 4 type S-shape transfer function and 4 V-shape transfer function. The second contribution is this enhanced SSA is applied to sentiment analysis in the Indonesian context from Twitter. And the third, to verify its efficacy, we compare our method again, well-known bio-inspired optimizer such as Underlying Optimization, ELO, and Particle Swarm Optimization, PSO. And the last contribution provides insight into the impact of different transfer function shape on the effectiveness of SSA in feature selection for sentiment analysis. And then here is the research methodology. As you can see from this picture, first starting from data collection. The data consists of 65,426 Indonesian language from Twitter. Next, text processing consists of scaffolding, tokenization, normalization, filtering, stop word removal, and stemming. And then while the labeling, we use Fodder library language expert to validate result from Fodder library. And then after that, we do data splitting with ratio 80-20 based on Jules Vicker et al. In 2022. From data splitting, 80% are treated to training the data with some selection technique, feature selection technique. We use SSA, PSO, Underlying Optimization, and then SSA with combined with transfer function, S1 until S4 transfer function versus V1 until V4 transfer function. And then the testing data, 20% data are treated as testing the data and directly to modeling using classification machine learning without using feature selection technique. And the modeling classification machine learning, we use KNN, K-nearest neighbor, naive Bayes, and SVM. And then the result of modeling performance evaluation consists of accuracy, F1 score, precision, recall, and running time. And then this is algorithm parameter setting. We use some parameter, instrument, and value. Okay, here is the comparison using performance modeling SSA. From 24 model that we already test using machine learning classifier algorithm and feature selection technique, looking at the result performance of algorithm show that performance result is not so different from each other from accuracy, precision, recall, and F1 score. But when a support vector machine with SSA algorithm using V1 transfer function have shorter time, namely 5.24 second, and high accuracy, namely 89.76% accuracy. Next. This is a part from the previous slide. We only improve STF and VTF in the algorithm SVM because the research result on the naive Bayes and KNN algorithm without transfer function have optimal accuracy and relatively have a fast processing time. Okay, the next is accuracy, precision, recall, and F1 sort. SSA with V1 transfer function and SSA V2 transfer function with SVM algorithm achieve the highest accuracy, namely 89.79%, outperforming other SSA variant with V-shape transfer function. The second is SSA with S1 SVM reach 89.43% accuracy with 4.38 second processing time. And PSO KNN have accuracy, namely 90.2%, and SSA KNN 90% still outperform SSA variant. The second topic is selected feature. SSA model with transfer function or without transfer function selected 47 until 50 feature, while maintaining accuracy 89% until 90%. And then PSO SVM selected only 14 feature with stable accuracy 89 until 90. And the processing time, SSA SVM had the longest processing time, 57.91 seconds. Next. Okay, this is conclusion and suggestion. The conclusion about context and challenge. Sentiment analysis on large scale dataset requires efficient feature selection to improve accuracy and processing time. Traditional meta-heuristic algorithm, SSA, PSO, ELO, have challenges in exploration and exploitation, leading to suboptimal performance. The second topic is proposed solution. We introduce an enhanced SSA with S-shape and V-shape transfer function, significantly improving accuracy and processing efficiency. The V2 transfer function and S1 transfer function variant enhance SSA exploration and exploitation, outperforming traditional method. And the last future direction, future work will address imbalance the data, the data imbalance, expand trial to multilingual sentiment analysis, and explore the others type, maybe X and U transfer function to further enhance SSA performance. Okay, that's all my presentation. Thank you for attention and listening. Thank you so much.
Thank you very much for the presentation and the effort that is apparent in your work. If any of the colleagues would have some questions for the presenter.
Dinar.
Dinar, what's the meaning of dinar? It's actually it's financially it's very clear. It's I appreciate. Yeah, this is the first. Second one, with the results you displayed before, that include many of techniques that should be used already there, and you compare your work with the others, and with the same data set or without the data set.
Okay, thank you so much, sir, for the question. We compare some model with one data set. We scraping data set from Twitter, and then we trial to each algorithm.
Yeah, yeah. Okay. And all of them written using at any language,
No.
standard English or
Okay. The last research, we writing the paper in journal itu to using the model, same the model, but using English in Twitter, but in English language. Okay, in accuracy not be optimal. We can we try again in the data from Twitter, but in Indonesian language.
Thank you.
Thank you so much.
Any other questions? Thank you, Prof. Hassanin, for your intervention. I have another question. You have mentioned at the end of the presentation here that one of the issues that you face is the imbalance of your data set. Because in Twitter, you'll find neutral tweets, you'll find positive tweets, and you'll find negative tweets. In the future, because you said that this is one of the issues that you're facing and you're going to fix this in the future, what is your intention or the roadmap that you're going to follow to mitigate this issue?
Thank you for the questions. The imbalance data so important for case sentiment analysis. Its impact for accuracy, precision, recall, and then maybe can overfitting, right? Now, this imbalance data for some machine learning, especially in naive bias, is very, very
Culture-wise?
I'm sorry, my
No
English
problem.
not so good.
No, it's very good.
Can impact to relativeness, accuracy, precision, recall. So important to
So
address imbalance data.
cleaning the data, the
Yes.
data set, the actual data
This
set,
the data.
cleaning the actual data set to convert it from imbalance to balance in a way so that you can train on it. This is one option.
Yes. In this research, we use imbalance data.
Yeah.
Maybe in the future, we must to concern in imbalance data to balance the data. So with accuracy, we see the accuracy is 89, the maximum accuracy of our model. Gitu.
Thank you very much. Thank you for your answers. Any more questions? Thank you. And
Okay.
we're going to move on to the next paper.
Thank you so much, Doctor. Thank you so much.
You have a question?
Okay.
In the next time slot, we're going to move to Prof. Hassanin. He's going to present the paper ID 898. You're welcome. Data generation in healthcare using constraint satisfaction parameters. عايز ده ولا ده؟ ده ولا ده؟ مايك. لا اونلاين.
هذا سكرين ده فورورد وده باكورد صح كده؟ شغال القلم؟ ليش؟
المهم انا محاضر.
ما كنا الثانية دي تشتغل كويس. لا لا أبدا. Okay. Good morning, everybody. Today we have some real application that generate data using new artificial generated model. This is what we mean by this topic. And this topic based on constraint satisfaction parameters that who compose this parameter, the expert people there, the doctor in healthcare, and maybe in added to some linguistic expert people also to prepare the data we need. This is first. And according to this scenario, with the introduction, you can use it in Next, in AI technology, and using the virtual reality and in education also as a biology and something like that. And the Next also for the education sector, and look at the traditional teaching methods. In added to, we have many of example about it. And after that, yes, doctor. Within the data science track, we have a framework to generate a data. The framework to generate any data includes 4 life cycle. The first step is related to descriptive. Second one, diagnostic. Third one, predictive. Fourth, last one, perspective, and so on. We have a scenario. This is a new branch with the computational sector as well, data science branch. When we go to create any data, we will decide which track we can use it to generate the data actually we have. Next. And therefore, we need to generate the data with this domain. What is the domain in healthcare? As a first example, that is related to depression, stressing, and anxiety. All of them is a chronic diseases. اللي هي أمراض العصر. This is what we mean. صداع, قلق, and something like that. And according to this one, and you have some data about GAN model, generative adversarial network model. We have 2 main modules. The first module, generator module. Second one, discriminator module. The generative module to generate any, at first, will generate it using a random data, randomly. This is the generator. And then to feed forward to the discriminator to take some example from the real data and they calculate or compute the difference between the fake data and the real data, and define the difference between them, and using backpropagation to enhance the difference according to the lossless or the lossy function between them. This is the scenario to use it, generator and the discriminator. Okay, next. Therefore, within our data, to generate the data, we have constraint satisfaction parameter that include the 5 descriptive dimension. You mentioned your question before related to the dimension. The parameter we need to generate the data. And one of them is related systolic data, glucose data, and so on. This is the standard parameters that already used in the healthcare. To generate all of this one, we have to use neural network and the hidden layers to generate the data, and then to decide what we need. This one is related to stressing. Second one is related to another one, and so on. If we have additional data that is related. The first one we mentioned about the text generation. Second one is related to the image generation. The question is how to use the new AI generated model to generate images that is related to this text as a description. We have a mapping between them. We have the text embedding to understand what's the meaning of this one, compare it with the image embedded that's generated from the image generation, and define the correlation between them. This description is related to this description of the image or not, and define it's similar or not similar. If it's okay, similar, it's okay. It's okay. Accept it. And then go to use another scenario. To enlarge the data set, actually, we need to build up. Again, our model, this one, constraint satisfaction problems based on this one scenario. After the generation, it's need few of microsecond, few to generate the data. Actually, we have the first around 20,000 data is generated. Then I go to generate million of record as maybe millisecond. Go to generate the data, add it to, and make it at the data set. And according to this scenario, I go to use the model we generated, the input. I go to it's like a prompt or like the rule or the query. You have a value that according to a specific value. This is the result. This is the generated data. The accuracy when we go to a measure is minimum at first is 92, and then I go to add additional data to enlarge the data, then train again the model, then test it. It's actually go to use 96 as accuracy. As well as we mentioned about discriminator and also generator. Between the generator and discriminator, we have what we call تسابق or معركة. It's okay. It's okay. And between them, you have the accuracy, the lossless, and you have discriminator accuracy. And what is the accuracy when I go to measure? Actually, when I go to measure this accuracy, it's around 50% or lower than 50%. This is another scenario to build up the GAN model. Also, this is the full framework for data generation, the constraint satisfaction parameter generator, and you have between them a discriminator, and then to find the lossless. At the end of this is what we call describe it. Next, this is the full phase. Prepare the constraint. The CSP is related to agent module in AI, and then generate realistic data, and then find to extract the feature we have, extraction, and then to analyze what we have, and then to mention about feedback, to write it. This is the result of confusion matrix. Actually, we have, and then also we can make a correlation between the different parameters that is generated. When we go to evaluate our model, we have different benchmark. The first benchmark is rated again, yes, it's a classical precision, recall, and F1 measure, and then accuracy. Second one is related to the matrix. It's a confusion matrix. It's like what we have. And then the qualitative evaluation is like CSP parameter. Go to the different people, the expert people there, and ask them about a specific scenario. This is the third benchmark. The first one, macro and micro. And then we have data set benchmark. When we go to a large data set, we have another measure. At the end,
this is the output of what we have. The conclusion, we used actually generated AI. It's very impressive. And as well, from 10 days ago, you listen about DeepSeek. It's open platform. The first one I got to use before ChatGPT, and then got to use as the second from 5 days ago to generate another data set. It's a very, very important scenario. Generative are impressive. And you have here many of challenges. The accuracy, actually, we have between 92 and 96. This is what I have with the scenario of to generate a real data set using a generative or the new generative model in AI. Any question? Thank you very much.
Thank
I
you,
got
Prof.
to
Hassanin.
minimize the time. Actually, we
Thank
have.
you very much for your comprehensive
Yes.
explanation of the paper. If any one of the colleagues has any questions, you have question?
Thank you, Dr. Barham. Thank you, Dr. Barham Tushi.
From Al-Jimum College
Yes.
and Qura University.
Hello. Yes. Thank you, Dr. Barham Tushi, for your presentation. My name is Dr. Tariq Al-Afif. I'm an associate professor in AI and computer vision. Basically, I have 3 questions. The first question: why did you choose a CSP? I mean, you can just go directly using
Yes.
the GAN, and why did you choose the parameters? That's my first question.
Yes. When I go to the constraint satisfaction problem, we have a constraint about the different values we have. The value of the temperature, as an example, or the heart pulse or impulse, is within a specific range. Therefore, you have a constraint. What's this one? To indicate what?
Okay.
To indicator to what? The relation between the data set we need to generate is a constraint. And this constraint satisfaction parameter to use an agent module. This is what I have.
Okay.
Yeah.
Okay, thank you. Second question, you can choose many specific features. Why you just only choose 6 features like BMI, glucose, and all this? It's just for experiment?
They are agree there with the expert people. This is a standard.
Standard, okay.
No variation between them.
Okay.
Yeah.
Okay. The third question, we know that generative adversarial network has 2 problems.
Yes.
First problem is the mode collapse problem. Second problem is there is no convergence at all. So since it's min-max game, so how
This
did
is
you
what we are
handle?
doing. Yes. Yes.
Yeah, how did you handle these problems?
And
Because it will generate biased data. So how did you handle this problem using the scan?
the data itself, no mention about balanced or not balanced. It's just to use the parameters as an indicator without any impression elsewhere.
Okay.
If we have it, that the last test we have is a GAN model. The GAN model, when I go to use it, it's not a real selection. But maybe it's maybe defect about the data itself. لكنه ما غير في شيء في الداتا.
I see. Okay.
يعني we have minimum
So you
threshold.
basically use the basic GAN structure because there
Yes,
there
the
are
basic
many
one.
GANs.
Yes, yes.
Many GANs out there.
Yes, yes,
Okay.
yes.
Okay. Thank you.
Thank you very much.
Thank you very much for attendance. I think that concludes our session because there's another session starting 10:30, inshallah. So thank you for your attendance, and we wish you enjoyed the session, and see you in more sessions in the future, inshallah. Thank you very much. There is paper ID number